Hello, welcome to the presentation Preference Learning and Aggregation from Natural Language. I am Farhad Mohsin and I'm working with Professor Lirong at the Rensselaer Polytechnic Institute. From our group of these authors, Lei is now doing his master's at Duke. Wufei will be joining Purdue to do his PhD next year. Zhibing is now in Microsoft and Rohit is at the Tata Institute for Fundamental Research. Now, preference solicitation is of course a major part of the group decision-making process. In elections, traditional paper ballots are used. Modern electronic polling platforms like Opera has multiple preference expression forms. But there's merit in the question of trying to elicit preference from more natural sources. So we try to answer the question, how can we learn agent preferences from natural language to make a group decision? An example of this case can be this discussion about which college is a better option for a fresh high school graduate. So here's our proposed framework to solve the problem. From text and discussion, we want to extract opinion features using established NLP techniques. To start off though, we noticed a lack of NLP datasets about the problem of group decision making specifically. So we created the college confidential dataset by annotating comments in a college admission forum with preferences expressed in said comments. Now we make use of popular sentiment analysis toolkits, but sentiment alone proved to be not enough to learn preferences. So we also run a stance detection algorithm to get more opinion features. Then we learn a preference model. We choose packet loose with features for us, which eventually gives us some advantage in the aggregation phase. And our packet loose with features model gives similar accuracy in predicting agent preferences when compared to complex models that make use of word vectors or neural networks in this domain. We finally compute aggregated results using various voting rules. In our experiments on the college dataset, we get around 67% accuracy when compared to ground truth aggregated results. Now, most of our theoretical contributions are in the preference aggregation parts. Voting with M alternatives in agents where each representative is expressed by a distribution over preferences, we can consider a probabilistic approach towards the vote, which would actually seem more normal. This would give a probability distribution over the winners, and this can actually be computed exactly if the distributions are known beforehand. For example, by using a dynamic programming algorithm defined by Hazen et al. But this turns out to be also computationally expensive. On the other hand, converting the distributions to fractional votes allow for efficient computation. For example, if an agent has 1/3 probability for voting for alternative A and 2/3 probability for voting for alternative B, in fractional profiles, we consider that as 1/3 votes for A and 2/3 votes for B. Then it becomes easy to compute for a multitude of different voting rules, and we have polynomial time computation algorithm to compute the winner for many different voting rules. And we also have a good property for this fractional winner anyway. So for any anonymous rule and any profile of distribution, the probability that this fractional winner is also a probabilistic winner is rather high when we have a moderate margin of victory. So this positive result gives us hope that our fractional aggregation scheme is actually a good idea. To summarize, we again mention our framework. We mine opinion features from text, learn preference models to predict agent level preferences, and then aggregate them to output a group decision. Our work is geared towards better AI for group decision making. We are working to extend our data set first and foremost. We want to explore the active learning techniques for efficient elicitation in text. As this is a very preliminary framework, I guess there is much scope for better models and algorithms, but we would also like to expand towards multimodal preference learning in the future with more natural sources of information like speech, gestures, or even things like emojis, and go on to deploy the framework in actual practical systems. So thank you to listening to my talk. Here are the references.